Greetings. Welcome back. This is a follow-up of my NanoEdge AI Studio demo. I'll have a link in the description for that video and to the project sources, as well as other links. In that project and video, I showed how I deployed a NanoEdge AI Studio anomaly detection model to an STM32 board, in that case was an H7, and got it running end-to-end. And what's unique about this project is that no physical sensors are required. So you don't have to buy a reasonably expensive board with sensors to get the experience. And for sensor-based projects, more realistic scenarios, ST Electronics recommends the B-U585I-IOT02A Discovery Kit, which has onboard sensors and is full NanoEdge compatibility. And my video, the original video, has a link to the tutorial of how to use that. Now, one thing I didn't like about my previous video on the project and its state is that it was tightly coupled with an H7 board, and so I did try it out with a STM32F4 type of a board, and I think it works good enough to where I can provide the data, the sensor data and the inference data, and this video is mostly concerned with how I created that data, and so I'm going to go ahead and provide that and walk you through creating the signals and the inference data and so on that will work with both boards. So in the description, I have a link to my GitHub, the anomaly detection project, to that first video, to a TensorFlow tutorial, and to my TensorFlow GitHub project. And the reason that's relevant is because I used the TensorFlow tutorial as a baseline. So here's that a tutorial intro to autoencoders, and the anomaly detection is further down in the page. And what's mostly relevant is downloading this CSV, this ecg.csv file. And it's in this format right here. It's 140 floats per row, and they're delineated by spaces. And so for TensorFlow training, it requires spaces. And that would be the same thing for NanoEdge AI Studio needs space-delimited signal data. It's called both normal and anomaly data. So while the training data for the TensorFlow requires spaces, to actually run inference or to query the built model, you need similar type data, 140 rows of floats, but comma delimited, or an array, if you're doing it locally, that's one of the options on my firmware. And the same thing with the embedded, not just the TensorFlow, but the embedded scenario requires the inference data to be comma delimited. So the process I use is I trained the TensorFlow model, and I loaded it into a script and sent it the data that it trained on, removing the labels if you read the tutorial, because it only expects 140 floats. Or you can keep it in and have your script deal with it and not read the 141st record. And then I just output the data and let the model define what was normal and what was an anomaly, because I found that there was a lot of overlap. So it wasn't 100% accurate to what it expected. So I had the model, I had a script that ran the training data as inference against the TensorFlow model. And when it classified it as normal, I had it write to the normal file. And when it classified it as anomaly, I had it write to an anomaly file. So the output was two files. And so since the output needed to be space delimited, those files were space delimited. And I used the .txt extension for space delimited and CSV for comma delimited when you look in the repository. I have two directories under NanoEdge underscore client, which has an inference folder, and then under that has the two boards and the inference data for the two boards, and it has signal data, and that's to be used for the NanoEdge AI Studio, which I'll show you here shortly. So here is NanoEdge AI Studio and its home page, essentially. And so we'll go ahead and we'll create a new project. And we're going to pick detect anomalies in your signal with on-device learning. So we'll create that. Now it remembers that I've been using two boards, a Nucleo-F401RE and a Nucleo-H743Z, and that's the one I started with. It's a more capable board, and the model it created is a bit more accurate, more stable, less variance in the inference runs. So since my board doesn't have any physical sensors, I choose sensor type generic. And then save. Now here's the step where we add signals. So I'm going to add signal, and this is the regular signal. These are the signals that do not have anomalies. Normal.txt under NanoEdge client signals. And we can take a look here, and it approves 140 floats. Now it has 3,395 rows. That's from the TensorFlow. This is basically the TensorFlow training CSV, but I've already divided it between anomaly and normal based upon the TensorFlow results. So we'll go ahead and import that. And then we'll add the anomaly signals obtained by the same TensorFlow output. We'll take a look at it, and it approves of the format. And it has 2,919 rows. We'll import that. Now here there's no save button or anything. They just have you advance along these steps. So there's project settings, which we've done. There's signals, which we just completed. Then there's benchmark, then validation, then deployment. So we'll do benchmark, and this takes a while, so I'll pause the video while it goes, but I'll let you watch the beginning of it. And so we're going to add new benchmark, and we're going to use the signals that we just added. So start. And see this hourglass going here, and it's at 2%. It's creating cross-validation data sets. What it's doing, it's querying a internal catalog, I guess, and it's searching for the best algorithm based on your board and based on your signal data. And so right now, at 5%, you can see the quality index is climbing quickly. It started at 40, it's almost up to 60. And so on. And so it's going to run for a few minutes. You can see that the anomaly data is well distributed. Where the this is the most important one. These two right here, the quality index and the balance accuracy, and they're at 60% now. And by the end of the run, they're going to be closer to 100. So I'm going to pause the video and let this complete. Okay, we'll check in on our benchmark. It's at 92%. It's going to take a while for it to finish, so I'll pause the video again, but it's tested over 45,000 libraries, and it's up to 70%, which I'm hoping it'll be closer to 100 while it's done. Although I don't expect it because it looks like it's flattened out, so I think it's going to be around 70%, which is not as good as what I've gotten previously, so that's interesting. So I'll pause the video again until it's complete. So I'll have to admit I didn't get great results on this run. The best thing is 72%, but It doesn't matter because you can use the library I checked in, or you can do it yourself and see if you get better results. Anyway, I'll show you what the validation or the deployment step looks like. So we'll just pick the first one, which is the best. Click on deployment. Now I choose embedded knowledge, so I don't want to train it. I find that it works well. I'll show you what that does. Get library, asks you what you are, and it compiles. Here, this just takes a minute. Okay, what it does is creates a zip file. And so when you extract the zip file, you get the knowledge.h, the lib, and the NanoEdge AI.h. Now I cover all this, how to deploy it into the project in the other video. So I think I'm going to call this good. It's gone on for 11 minutes. So anyway, I hope you found it helpful, and thanks for your attention.